Hi everybody, another video for you. This one is number 42, and I chose it because it had a lot of fractions. And I wanted you to see that the process works the same, just so you have an example of it. So again, we are dealing with, converting it to the vertex form, trying to see what happens in terms of the base function. Let me just scroll down and I'll read the answer again first, and we'll talk about the range real quickly at the same time. So what's going to end up happening is we're going to have a vertical shift down of 5/3 units, and that's where this comes from. We're going to have a vertical compression because the number is less than 1. So this lead coefficient or factor is actually going to be smaller than 1, and so it's growing at a rate slower than 1. And then we call it a compression when it's smaller than 1. And it's a shift horizontally left because it's +1. When it's inside the argument, remember it moves the opposite direction. And then our range, since this is positive, it opens up. And so our y is going to be greater than or equal to -5/3. Okay. And we just get that from the vertex. Now, let's get this, which is in standard form, into vertex form so we can see it. We need to begin by getting this coefficient equal to 1. So we're going to multiply by 3/2. And the reason that's the case is 3/2 times 2/3. They're reciprocals of each other. They will reduce down to, if you multiply straight across, 6/6, but if you cancel it, you're going to get 1/1. The 3's are 1's, and then when you cancel them, the 2's become 1's when you cancel. So 1 times 1 is 1, 1 times 1 is 1. But if you want 3 times 2, you get 6, or 2 times 3, you get 6, and 6/6 equals 1. Anyways, that's where that comes from. So I need to multiply this by 3/2, but I can't just willy-nilly just put a 3/2 there. I have to respect the fact that I have an equation. And so every term in the equation will get multiplied by a 3/2, including this thing. So we end up with 3/2 times f of x is equal to 3/2 times 2/3. You get the cancellation. You have 3/2 times 4x/3. Well, those 3's cancel, and this 2 goes into itself once and goes into this 4 2 times. That's where we get the 2 from. And 3/2 times 1 is just 3/2. Now, we've got to create the parking lots. And so we put our parking lot after the f of x, and we put a parking lot after the 2x. So the middle term, and we create a space, and we move this constant farther away. All right, take the middle term. 1/2 times 2 is 1. So we take half the middle term, and then what we get here, we square. And so we're going to put a 1 here and a 1 here. All right. So now I'm looking at 3/2 times f of x plus 1 is equal to x squared plus 2x plus 1 minus 3/2. This piece here is now a perfect square trinomial. It will factor to x plus 1 times x plus 1. And just a quick note, what you get right here every time is what you're going to have right here. It's a positive 1, so it's going to read +1. Okay. So now, I can rewrite this as 3/2 times f of x plus 1 is equal to the quantity x plus 1 squared minus 3/2. I should read that as the quantity x plus 1 squared. Now, I have 3/2, and that's negative, minus 1. All right, I need a common denominator, so 1 becomes 2/2. So I'm really looking at minus 3/2 plus a negative 2/2, which gives me a negative 5/2. I'm going to now have 3/2 f of x is equal to x plus 1 squared minus 5/2. I'm going to undo this work of multiplying by 3/2, and I'm going to multiply by 2/3 to get it to 1. But if I multiply here by 2 over 3, I've got to multiply by every term with a 2 over 3. So here they will cancel. Here I'm going to have a 2/3, then x plus 1, again the quantity squared, and then I multiply this term by 2/3, and the 2 2's cancel, and so I'm left with 5/3. Okay, so again, here's my vertical shift, here's my horizontal shift, and it goes the opposite way of the sign, and here's my vertical stretch or compression, and since it's smaller than 1, it's a compression. Okay, I hope that helps.